I thought I'd used up every PCIe lane in my system. GPU, NVMe, NVMe, and yes, even more NVMe, but nowhere to plug it in. That's when I found two little ports hiding on my Supermicro motherboard. OCuLink. In this video, I'll show you how to use those ports along with some adapters that keep it clean to add two more NVMe drives at full PCIe speeds. No weird hacks, no risers, no sketchy parts. So let's dive in. My NAS build runs a Supermicro motherboard. It's a server-grade motherboard with plenty of PCIe lanes, but they do go fast. If you've been following along, I recently did a video on upgrading the server, so if you want the full backstory, go check that out. Right now, here's what my PCIe layout looks like from top to bottom. At the top, I've got an RTX 2000 8th generation GPU. It takes up 2 slots and uses a full 16x of lanes. Below that is a carrier board that holds 2 NVMe drives, running bifurcated X4, in an 8x slot, which works great. Then there's another single NVMe carrier, but it's in an 8x slot that's only wired for X4. So I'm stuck with just one drive there, no room to expand. That left me totally out of PCIe room for adding any more NVMe storage, and that's when I started looking for alternatives. While digging through the manual, I noticed 2 ports labeled OCuLink 1 and OCuLink 2. I hadn't used them before, but after a bit of research, I realized they can each provide 4 PCIe Gen 3 lanes directly to the CPU. That's basically the same bandwidth as a full X4 NVMe slot, except for it's just a tiny internal connector. Now, OCuLink was originally designed as a compact way to connect storage devices directly to PCIe lanes, mainly for enterprise systems and servers. But it's also shown up in some pretty weird places too. You'll sometimes see it used in GPU mining rigs or even on small form factor video card breakouts. It's rare, but that also means that there's a weird mix of adapters out there. Some are for NVMe, some are for GPUs, and not all of them are built the same. So if you're out of slots but you have OCuLink ports, you're sitting on a hidden upgrade path. The tricky part is connecting a standard NVMe SSD to an OCuLink port. You can't just plug this directly in. NVMe uses edge connectors while OCuLink expects a U.2 style interface. On top of that, NVMe drives need power, which OCuLink cables don't provide, so I needed 2 things. An adapter that converts M.2 NVMe to U.2, and a cable that goes from OCuLink to U.2 with power included. If you're not familiar with U.2, it's basically a server-grade interface for NVMe SSDs. It uses the same PCIe protocol as M.2, but comes in a 2.5-inch drive form factor with a different connector that supports enterprise features like hot swap. It's mostly used in data centers, but the cool part is, with the right adapter, you can convert a standard M.2 NVMe drive to a U.2 drive and plug it into systems that support it. This adapter converts a standard M.2 NVMe SSD into a 2.5-inch U.2 compatible drive. No tools needed, just slide in the drive, snap it shut, and it presents itself as a U.2 interface on the back.
So if we take our NVMe and put it into here and push down, it's locked into place. It's pretty nice that this is toolless, because if you need to get it out, just push up and it pops out. Probably see it a little better like this. Yeah, so it pops right out, so pretty nice, toolless. So they did include some additional thermal pads. So if these chips are uneven, you can place some additional ones here to kind of level it out. On the 990, it's pretty flush. I won't need to do that. I just place the one thermal pad on here, and then we just snap this into place. And there we go.
Now it claims speeds up to 8,000 megabytes per second, which is more than enough for my Gen 3 X4, and it's compatible with Gen 4 too, if your system supports it. This isn't sponsored or anything, I just genuinely appreciate that IcyDock makes weird niche adapters like this. Without it, this setup wouldn't have been nearly as clean. For the cable, I grabbed this cable decon adapter. It connects the OCuLink port on the motherboard to a U.2 drive and includes SATA power connector for SSD. Now I bought 2, one for each port. Now these aren't from a name brand, and I'll be honest, it was a bit of a gamble, but the reality is there weren't many options out there that included the power and matched the U.2 spec.
And that would be this cable right here. So this cable goes from OCuLink, which plugs into the motherboard, and then on the other side, this is U.2, and then we have a SATA power to pull power from our power supply so we can inject power into this carrier board right here. So it should be as easy as just plugging this in. You'll want to be careful if you could see that. There's a little riser right here and there. You'll want to just make sure that you match these up and connect them. And so you can see that this cable, it was made. I got it off Amazon. We'll see if it works. I do wish there was a better solution, but we'll see if this cable works. Should work. So a lot of people ask why I put RGB in my server, and yeah, most of it is for looks, but it also helps out when I'm working inside. So I can turn on the lights, turn them up brighter, or I can make them blue just for fun. I keep them a little bit blue. That kind of looks okay. So the OCuLink ports are right here on my motherboard. Might be kind of hard to see, but there are two little ports right here on the edge. But then we want to insert this end into there, and it does have some grips. It has some teeth. Once you push it in, it should click in, and if you need to release it, you just press these and those will lower those pins. So now let's install this. It should only go in one way, and you should hear a click or multiple clicks, and then once it's in, you know, it's not going anywhere until you press the release button. So since this is a standard 2.5 inch drive, I can actually put it right here in my mounting bracket. Now I'm going to adjust this later on, probably have both drives on the outside so they get most of the air, but as you can see, that fits right there. And then the last thing to do is grab power. Let's grab this one just while we're testing, and I'll clean up all of these cables later. And again, this only goes in one way, so don't force it. Kind of tuck these out of the way for now, and we can give it a shot.
And then on the next boot, the system picked up both drives with no drama. So I just booted up my server, and if I go into storage, I can see that I have 2 additional disks. I originally had 3, but now I have 5. And if we take a look at these disks and I sort them, I can see some additional NVMe drives. I tested the setup using a Samsung 990 Pro, and everything's running on Linux. First, let's list all of my NVMe drives, and we can see all of my drives here along with their serial number and their models. Then I want to match those to PCIe lanes. I know that mine right here are 17 and 18. So now let's check the PCIe Express generation and make sure we're getting the bandwidth we should be getting. I can see that it is negotiated at 8 gigatransfers, which is PCI Express Gen 3, which is the limit of my motherboard. So that's a good sign. And we're also getting all X4 lanes. And if I do the same for the Optane drive, I can see it's negotiated at 8 gigatransfers. I'm getting 4 lanes. So this is a good sign. The cable and the carrier board aren't limiting my connection to the server. Then just to check really quick if these are being throttled right now, even though they're not doing anything, I can see no, they're not being throttled, and they haven't been throttled, and they're ranging around 41 to 45 degrees Celsius, which is totally fine. I think 60 or 70 is where they start to throttle. So Samsung is good. And the same for the Optane drive. They haven't throttled, aren't throttling, and they're around 40 degrees Celsius. So these look good too. I use FILE from the command line to run a sequential and a 4K random test. Here's what I ran for the sequential read and writes. So let's see what these Samsung drives can do. I'm running a sequential read and write on that 990 Pro. So if we look at the results here, we can see about 3,000 megabytes per second read and write. So this is really good. This means we're not getting limited by PCI Express. So we're getting the maximum amount of bandwidth we can get. And then if I run the random 4K read and write test, you can see these are really good too, about 2,000 megabytes per second. So these are classic strengths of NAND flash, and you can see that these are performing really well. But how does that compare to my Optane drives? Well, if we run the same test to sequential read and write, we can see that I'm getting about 700 megabytes per second on read and write, so much slower. And if we run the random 4K read and write on those Optane drives, we're seeing about the same thing, a little bit more, 630 megabytes per second. So you might be wondering, why would you even buy an Optane drive over a consumer drive if a consumer drive outperforms it on read and writes? Well, the answer is in consistency and latency. Just to illustrate this and to measure latency, I'm running this test on the 990 Pro. If we look at this test, we can see that the average latency for this drive is about 25 microseconds. And if we look at the 99th percentile, it's about 55 microseconds, and the 99.9th percentile is about 72 microseconds. So now let's compare that to the Optane drive. If we look at the Intel Optane drive, we can see that the average latency is about 9 microseconds. The 99th percentile is about 12 microseconds, and the 99.9th percentile is 24 microseconds. And so this drive is 3 times faster or has 3 times less latency than the Samsung 990 Pro. So this test is really to illustrate kind of a worst case scenario with only one queue depth, meaning it'll only process one request at a time. And this is really worst case latency. But you could see here that it outperforms that Samsung drive by a long shot. And so that's why a lot of people choose these Optane drives, not only for their latency, but also for their consistency too, and their longevity. So they're really great for caching or reading lots of tiny little files, especially like a metadata drive or a log drive, or if you're caching lots and lots of files, say for a web server, these are really great for cache. And so that's why a lot of people choose these drives, and I just wanted to show, kind of illustrate some of the strengths and the weaknesses of both drives. And this test wasn't to choose a winner or say that one is better than the other. The Samsung wins on throughput, and the Optane drive wins on latency by far. So they're really different use cases for each drive. If you want raw speed and raw transfer speed, the Samsung 990 is going to be a good bet. But if you want low latency, say for metadata, logs, or databases, the Optane is going to win hands down. And this also showed that I was able to add 2 more NVMe drives without the need for more PCI Express lanes because I use the OCuLink ports on my motherboard. Now, what I like most about this upgrade is the flexibility. You're not limited to consumer M.2 drives. You could use enterprise U.2 SSDs down the line. And because OCuLink is just raw PCIe, there's no overhead, no drivers, no surprises. This whole upgrade took maybe 30 minutes, and it added 2 full-speed NVMe drives to my NAS with almost no complexity at all. Just 2 adapters, 2 cables, and a bit of routing. No BIOS tricks, no special drivers, no tuning, no nothing. If you've got OCuLink ports and weren't sure what to do with them, I hope this helped. Let me know in the comments if you've tried anything with OCuLink or if you've run into any weird adapter issues. I've got more NAS experiments and NAS guides coming soon, so if you're into that, feel free to subscribe. I'm Tim. Thanks for watching.